In this lab, we'll be using pasta to represent bacterial cells and toothpicks and clothespins to represent the antibiotics that destroy them. You'll see how quickly bacteria can multiply, why the correct dosage of antibiotics is important, how bacterial mutations can cause antibiotic resistance, and the difference between broad spectrum and narrow spectrum antibiotics. We're going to start with a population of 20 initial bacterial cells. Using the toothpick to represent the antibiotic, we'll remove as many bacteria as possible in 15 seconds. This represents 1 day. 15 bacteria have survived, and they reproduce asexually by binary fission. After duplicating the bacterial cells, we use the antibiotic again for days 2, 3, 4, and 5. Now we'll increase the dosage of antibiotic, which we'll represent by using 2 people to remove the bacteria rather than 1. We start with the same initial 20 bacterial cells. In part 2, we'll see some bacteria that have picked up a genetic mutation, which changes their shape. Starting with the same 20 bacteria, but 6 of them have picked up a mutation. We'll use the same 200 milligram dosage of picosilin from part 1, and watch the population again for 5 days. When all data is recorded, this is the end of part 2. In part 3, we'll use the same initial 14 bacteria and 6 mutated bacteria, but we'll change to a different antibiotic represented by clothespins instead of toothpicks. And finally, both strains of bacteria have been eliminated.